So now, in part 2C of lab, we will consider a third measure, the clustering coefficient, and look for the number of completed triangles in a network. To compute the clustering coefficient, we will not write the code ourselves. Instead, we will download this code from a site on the internet. That site is listed here at line 156 in the code. And if we go there, we're going to download a single function, clustering coefficient underscore BU. So I've gone to this web page, and I'm looking for that function. And I know it's down under this heading, clustering and community structure. And we'd like to download this single function, clustering coefficient underscore BU. BU here does not stand for Boston University. It stands for binary undirected network, which is the types of networks we're interested in here. So save that file into your directory. I've already done that. So I've downloaded this file, saved it in my directory. You can look inside and have a peek at that file if you're interested. It's been written by experts in the field, so we can trust that it works. And we'll use this to analyze our adjacency matrix A. So I'll bring up our MATLAB window here. So here's our MATLAB window, and we'd like to use the clustering coefficient underscore BU, apply it to our network A. And if I do that, what do I find in this case? Undefined function or method, clustering coefficient BU. So what's wrong here? Well, I'm in the wrong folder. Now let's navigate to the right folder. I'll hit up arrow and try to compute this command again, and I see it doesn't crash. We get a result. So we get the clustering coefficient. And we can see what is the size of clustering coefficient. So what is its size of clustering coefficient? We see that it's 5 by 1, so 5 rows in one column. We can look at it, and we see it consists of all zeros. And then we can ask, is that consistent with our network? Clustering coefficient of each node is 0. Now, are there any completed triangles in this network? The answer is no. There are no completed triangles in this network. So we expect the clustering coefficient for every single node to be 0, and that's what we find. For node 1, the clustering coefficient is 0, node 2 it's 0, node 3 it's 0, and so on. So it does make sense. It is consistent with this simple network. We can also compute the average clustering coefficient, and so I'll do that now. This is a summary measure for the entire network. You can probably already compute in your head what the average should be. If they're all 0, then their average clustering coefficient, let's look at it, the average clustering coefficient should also be 0. And that's in fact what we find. So we've computed the clustering coefficient by downloading a piece of MATLAB code from somewhere else. We found it matches our expectation, and we'll apply this measure to more complicated networks as we go along.